Hello everyone, welcome to today's class. The topic that we are going to see today is Introduction to Computer Programming and Applications. A computer is a useful tool for solving a great variety of problems. To make a computer do anything, that is solving a problem, we have to write a computer program. In a computer program, we tell a computer step by step or sequentially exactly what we want to do. So a computer program can be defined as the following. A computer program is a collection of instructions that can be executed by a computer to perform a specific task. Moving on to computer programming. So what is programming? Understanding a problem for which a solution is required. So in order to develop or design a solution, firstly, we need to understand a problem, right? Then we move on to designing a solution. After that, we write the code or the program in the programming language. Then we test the code in order to see if there is any errors or not. If there are errors, then we correct those errors. And lastly, we maintain the program. So all of this includes in what is a programming, right? Moving on to the concept of computer languages. Computer languages are used for communication between users and computers mainly. So there are three types of computer programming languages. The first one being machine language, the second one is the assembly language, and the third one or the last one is the high level language. So in machine language, what we have is basically strings of number giving machine specific instructions. So this string of numbers are mainly by zeros and ones. So these numbers constitute of mainly two digits, 0 and 1. And in this manner, these strings of number are able to give specific machine instructions to our computers or devices. Moving on to the assembly language. So these assembly languages are basically English-like abbreviations, okay? And they represent our elementary computer operations, which are translated via the assemblers, okay? So we will see later on what this assemblers is, but for now, we just need to know that in assembly language, we use English-like abbreviations. Say, for example, load base pair. So this is a command in assembly language, and this represents elementary computer operations. Similarly, for elementary computer operations, we can say add, right? So there is this add, which is also an English-like abbreviation, and it falls in assembly language. So like this add, we have mul, mul, which is also it stands for multiplication and is also an English-like abbreviation. Okay, so the abbreviations for add and mul is addition and multiplication. Similarly, it goes like div. So this all of these commands falls under the assembly languages. Then we have the high level languages. So the codes which are similar to our everyday English, those are our high level languages. So we use mathematical notations which are translated via the compilers. So all of these languages, in order for the machine to understand them, we have to translate them. Okay. And for assembly language, we use these assemblers for translating the assembly languages into machine readable languages. Okay. And for high level languages, we use compilers. So these are used for converting or translating our language, assembly or high level, in machine readable languages, okay, so that the machine can understand that. So basically these two languages are converted to this machine language in order for the machine or device to understand, and we use assemblers or compilers to do so. For assembly language we use assemblers, and for high level language we use compilers. Now an example of this high level language is given here. As you can see, the gross pay equals to the base pay and the overtime pay, and we use the addition and equals to sign here, which corresponds to our high level language. So we don't use English like abbreviation here, we use codes which are similar to our everyday English language. Okay, so moving on to the next part, which is the evolution of these three languages. Now let us see the evolution of the three languages, which are the machine language, the symbolic or assembly language, and the high level language. So in 1940s, the evolution of these languages started. So the inception of the development of machine languages started from 1940s. Then as time progressed, in 1950s, the development of assembly language or symbolic language started. Okay. And as the time even further progressed in from the 1960s, the development of high level languages started. Okay. So the first major programming language breakthrough came in 1972, which was done by Dennis Ritchie at Bell Labs. So Dennis Ritchie at Bell Labs, he created the programming language C from two previous programming languages, which is BCPL and B. Okay, so before the major breakthrough of the programming language C, there were two other programming languages, BCPL and B. So this programming language C, it was originally created to design and support the Unix operating system. Okay, so C was mainly intended to develop, to design and support the Unix operating system. But later on, this was standardized by ANSI. Okay, so ANSI is a American National Standards Institute, and in 1989, after ANSI standardized this, it was known as ANSI C. Okay. Then later on, the international standard ISO, okay, this is an organization, it approved this programming language C in 1990, and it was later on adopted by ANSI, okay, and was known as C89. Okay, in 1990, the programming language C was known as C89. Now, as part of the normal evolution process, the standard was updated. So in 1995, as this was updated, the language was known as, the current standard was known as C95. And in 1999, it was known as C99 or ANSI C. Okay. Now, the current standard that nowadays people use is known as C11. So there are some programming languages that are based from C or which are influenced from C. So the first one is C++. So this C++, this programming language, it includes all the features of C, classes, and other features. Then we have Java. So this programming language Java is largely based on C++, and it inherits many features of C. Then we have C sharp. This is mainly derived from C++ and Java combined. After that, we have Perl language. So this is basically a simple scripting language and which adopted many features of C. Then we have JavaScript, right? So JavaScript is the syntax that is used by JavaScript is heavily influenced by C. So moving on to some of the applications of C, we have OSS, operating systems like Linux. So Linux is mainly developed by the programming language C. Okay. Then we have microcontrollers, right? So microcontrollers includes automobiles and airplanes. So the microcontrollers that are used in our automobiles and airplanes, they are they are largely programmed through C. Okay, so the language C is used for designing the microcontrollers or programming the microcontrollers. Okay, then we have embedded processors and DSP processors. So embedded processors include phones, portable electronics, okay, and DSP, which means digital signal processing. Okay, it includes your digital audio and TV systems. This processors include the programming of C language. Okay, so C programming language is used to program some of the specific tasks in these processors. So moving on to the importance of C. Now, C is highly portable. So what does this basically mean, highly portable? So it means that it is used for scripting system applications which form a major part of Windows, Unix, and Linux. Okay, so that is why we say this is highly portable, since this scripting system application can be used in Windows. Okay, so Windows, we can use this in Windows. Then we have what, Linux. Okay, so that is why this is highly portable. Then we have the second importance, which is efficient and fast. Okay, so C implements algorithms and data structures swiftly, facilitating faster computations in programs. So this has enabled the use of C in applications requiring higher degrees of calculations like MATLAB. Okay, so in MATLAB we can see that there is the integration of C, which because since it implements algorithms and data structures swiftly, so it facilitates faster communications. Okay, and also on the other hand, this is efficient. So C is basically a general purpose programming language and can efficiently work on enterprise application, games, graphics, etc. Okay, now moving on to the next importance, which is structure. So C is a structured programming language, right? So C is a structured programming language. It allows a complex program to be broken into simpler programs called functions. So it also allows free movement of data across these functions as well. Then lastly, we have the ability to extend itself. So basically C as a middle level language combines both the features of high plus low level languages. Okay, so it can be used for low level programming such as scripting for drivers and kernels, and also it supports the functions of high level programming such as scripting for software applications. Okay, for software. So this is all for the importance of C. Let us move on to the next topic, which is a typical C program development environment. So in a typical C program development environment, we can see there are some phases of C program. So the first phase is the edit or create. Okay, so C program files name should end with C or CPP extension. So the environment that you are coding in, the file that you are coding or the language that you are writing, that file should have a .c or .cpp extension. Then you have the next phase, which is the compile, and then we have link, and lastly we have the execute. Okay, so from this diagram, let us see what is happening, okay, for a program development environment in C. So firstly, we have our program code, right? This is our code where we are writing our code. In the system, if it's ready, we enter the program, right? Then we, in this program, we can edit our source program. Okay, after editing our source program, after everything is finished with our source program, if our source program is complete, then we move on to the next stage, which is the compilation of our source program. So this compilation is done via the C compiler. Okay, now in compilation, two things can happen. So firstly, there might be some syntax errors. Okay, if there is a syntax error, if it's yes, then we have to edit our source program again so that there are no errors. Okay, so we keep on doing this until there are no errors, until we are here in no. Okay, so okay, let me erase this. Okay, so until there is no errors, we keep on cycling this. Okay, then we have the next phase, which is the link, right? So here we have a linker. So what does this linker do? So after compilation, a sample object file is created. Firstly, for the program code, a sample.c file was generated, which is the basically the initial .c file that stores your program code. Then after the compilation, this program source code is converted to an object code, sample.object. Okay, so this is basically a machine readable language. That is why we use the compiler in order to convert the source program to a machine readable language, which is which has the extension .o or .obg. Okay, so what does the linker do here? The linker links this sample object with the system library. Okay, why does it do that? This linker links it with the system library in order to create an executable file, which is the sample.exe. Okay, so let me say it again. After the .c file, okay, which is our main program, is compiled, it will turn into a sample.object or o file, okay, .o or .obg file. This obg file is then linked with the system library in order to create a sample.exe or an executable file. Okay, after this is created, we move on to the next phase, which is the execute. Okay, so here what we do is we execute the object code that we have just developed, okay, through the linker. So after the linker produces an executable file, this executable file is executed one instruction at a time. If there is any logic or data errors, if it's yes, then we move on to the edit source program, and then again we have to start the cycle all over again. We have to compile it, we have to again link it, and then we have to execute the object code. So we keep on doing this until we find that there is no logic or data errors. Okay, if there is no logic or data errors, then what we do, we can give an input data finally. So after we give an input data finally, okay, it executes the object code, and then if we get the correct output, we can stop. Okay, so this is basically a typical C program development environment. To surmise what I have said is that firstly, when the system is ready, we can enter the program code that we have given initially, that we are writing initially into the system. Then we can edit the source program. Afterwards, the program that is we are editing is saved in a sample.c file. Okay, this is the .c file. Then we compile this sample.c file. Okay, we can get syntax errors or not. If we don't get any, if we get in syntax error, then we have to edit it again. If we don't get it, then sample.object or .o file is created, right? So this basically is an object code that has been created after the compilation, and this object code with the linker will produce a executable file, which is the sample.exe file. Okay, then this exe file is executable. Now if this has any logical or data errors, then we have to again go to the edit source program and edit it. And if it doesn't have any logic or data errors, then we can just give some input to it. And if it doesn't have any logical or data errors, by giving it the input, we can get the correct output, and finally we can stop. So this is the process of compiling and running a C program. Okay, so these are the phases that I have just described just now. So the phase one, we are creating your program with an editor program. Okay, and this is in the .c file, right? This is the .c file. Then the phase two is similar to that of the phase one. We will cover this phase two later on in our upcoming classes. Now, in the phase three, we have the compiler, okay, which compiles the computer program into machine readable language, which is the object code, right? So here, this file is saved as .o or .obj, right? In that file name. Then in phase 4, we have the linker, which links the object code with the code in library or system library to produce an executable file. Now this executable file, the CPU, the central processing unit, executes this program one instruction at a time. So this is all for our typical C program development environment. Okay, now let us move on to the writing programs or integrated development environment, which is our IDE. Okay, so what is an IDE? An integrated development environment, IDE, is a software application that provides comprehensive facilities to computer programmers for software development. So this is integrated with compiler, building executables, and a debugger. So in our IDE, we have all of the individual extensions and components which are required for compiling and running a program. So this is very convenient for larger programs. It means that in an IDE, basically and essentially, we can do everything. We don't have to manually download or install any plugins. All of the things are present for running and compiling a program. Now, some of the popular IDEs we have is Eclipse, then Microsoft Visual C++, Code Blocks, and Xcode. So we will be using these code blocks for our IDE. The last part we have is the computer programming application fields. Now, in the computer programming application fields, we have machine learning, okay, artificial intelligence, we have robotics, and then we have a database technology. We also have software and application development. And lastly, we have networking and telecommunications. So beside these fields, there are a lot of fields in which computer programming is applied. Okay, so these are mainly the fields that computer programming is a must. Okay, So this will be all for today's class. Thank you. Hope you have understood and enjoyed the class as well.